Hello everyone, कैसे हैं आप सब? So again I welcome you all to my channel and this is Ankita. So in today's lecture we will discuss about F-block elements. In our previous video we already discussed about D-block elements in detail. That is also known as transition elements. So now onwards we will discuss about F-block elements. That is where they are placed in the periodic table, how their oxidation states vary, their atomic radii, ionic radii, their properties, everything. So first come first, F-block elements are also known as inner transition elements. Okay, so there are two series which are placed at the bottom of the periodic table, which are also known as lanthanoid series and actinoid series. Okay, so the lanthanoid series starts from lanthanum, whose atomic number is 57, and ends on lutetium, whose atomic number is 71. The next series starts from actinium, whose atomic number is 89, and ends on lawrencium, whose atomic number is 103. So all the elements which are present after lutetium and lawrencium, they are placed in D block. Okay, we already studied that. So I hope you are watching all the videos. Again, I already given you some trick to learn this inner transition series, but I will repeat that. Okay, so the first series which you have to learn is lanthanoid. So आप इसे learn कैसे करोगे? It's very difficult to learn all the name. Okay, so using the symbols we prepared a sentence, and from that sentence we will try to remember the names of the elements. Okay, so the sentence is in Marathi. Please listen carefully. लाल शिऱ्याचा प्रसाद नंदूने प्रधानमंत्री श्रीमती इंदिरा गांधी यांना तबक्यात दिला हो. इराकचा तंबू याकूबने लुटला. Okay. Now LA is for Lal, CE is for Shira, PR is for Prasad, ND is for Nandu, PM is for Pradhan Mantri, SM is for Srimati. So it is Lal Shiraza Prasad नंदू ने प्रधानमंत्री श्रीमती कौन थी हमारी फर्स्ट प्रधानमंत्री लेडी इंदिरा गांधी. ओके, तब क्या था टीपी मतलब प्लेट, तब क्या मतलब प्लेट होता है. ओके, सो तब क्या दिला हो इराक, ER फॉर इराक, TM फॉर तंबू, YB याकूब ने लूटला. ओके, कुछ फनी सा है. सो जस्ट learn this and I'm damn sure कि पूरी सीरीज लर्न हो जाएगी. ओके, नेक्स्ट इज एक था पैदल चलने वाला. ओके, AC से एक था पैदल चलने वाला. U से उसने नेपाल, NP फॉर नेपाल, PU पूरा, AM अमेरिका, CM फॉर कनाडा. आई नो लिंक नहीं होता बट स्टिल कनाडा, BK बैंकॉक का सफर, CF फॉर सफर. ओके, ES फॉर 41 दिनों में पूरा कर. जस्ट टू लिंक द सेंटेंस वी एड सम वर्ड्स. ओके, 41 दिनों में पूरा कर. FM is for first, MD is for middle, NO is for number, LR is for लेकर रखा. So एक था पैदल चलने वाला, उसने नेपाल पूरा, अमेरिका, कनाडा, बैंकॉक का सफर 41 दिनों में पूरा कर. फर्स्ट, मिडिल, नंबर ले रखा. Okay, now I hope it is clear to all of you. So now we will go in some detail of F-block elements. Okay, now Why these elements are known as F-lock elements? Because the elements in which last electron on the differentiating electron enters in n minus 2f orbital of the atom. Okay, that's why they are known as F block element. कौन से orbital में जा रहा है? F में जा रहा है. कौन से F में जा रहा है? तो n minus 2. That is also known as pre-penultimate shell. In case of D block elements, we already studied that electron is entering in penultimate shell. Penultimate shell कौन सा होता है? n minus 1. That is last but one shell, right? तो इलेक्ट्रॉन कहाँ जा रहे थे? डी ब्लॉक में n minus 1 D में जा रहे थे, right? In case of inner transition elements or F block elements, electrons are entering in pre-penultimate shell, that is n minus 2. Okay, तो अभी F orbital में जाएगा तो it is n minus 2 F. Okay, hope it is clear to all of you. तो इसे it is also known as n minus 2 shell is also known as pre-penultimate shell या फिर anti-penultimate shell. This thing you have to remember कि pre-penultimate shell किसे बोला जाता है और anti-penultimate shell किसे बोला जाता है. तो it is n minus 2 shell. Okay. Now, why this F-lock element is known as inner transition series? Because they are placed within the transition series. D block को transition इसीलिए बोला गया था because they show the transition in the properties as you go from S block to P block. And this series are placed within the transition series. That's why they are known as inner transition series. Okay, and one more reason कि electrons are entering in F orbital which lies much inside the D orbital. Okay, so that's why they are also known as inner transition series. So the general electronic configuration for this D F block element is n minus 2 F1 to 14 n minus 1D 0 or 1 ns 2. So just remember one thing, the outer shell ns shell is always fulfilled. It will be always 2. Okay, F में it varies from 1 to 14. इससे ज़्यादा नहीं हो सकता because in F subshell there are 7 orbitals. Okay, तो maximum accommodation power of F orbital is 14 electrons. D में it can be 0 or 1. So if n is equals to 6, consider n आपका principal shell is 6. तो इलेक्ट्रॉन कहाँ एंटर होंगे? इट विल एंटर इन n minus 2. तो 6 minus 2 तो कितना होता है? इट्स 4. और सब शेल कौन सा है? F. तो 4 F में इलेक्ट्रॉन एंटर करेंगे, राइट? एंड कंसिडर इफ n इज इक्वल्स टू 7 तो 7 minus 2 तो इलेक्ट्रॉन विल एंटर इन 5, right? Electron will enter in 5f, right? So that thing you have to remember. Okay, I hope it is clear to all of you why they are known as F-block elements, why they are known as inner transition elements. Penultimate किसे बोलते हैं, pre-penultimate और anti-penultimate क्या है, and general electronic configuration. Okay, so next is, we already seen that there are two inner transition series. One is known as lanthanoids and other one is actinoids. Okay, so on what basis these elements are distributed in two series? That is on the basis of your differentiating electron. That means if your differentiating electron is entering in 4f orbital, then it is lanthanoid, and if it is entering in 5f orbital, then it is actinoids. Okay, so it is lanthanoids is also known as 4f series because your differentiating electron is entering in 4f orbital, and actinoid is also known as 5f series. Okay, now lanthanoid is also known as first inner transition series, and actinoid is also known as second inner transition series. Okay, so this thing you have to remember. Lanthanoids कभी कभी इन्हें लैंथेनाइड सीरीज भी बोला जाता है. ओके, they are also known as lanthanide series, and actinoids are also known as actinide series. Okay, why? Because they belong to the, or they follow the lanthanum and actinium respectively. Okay, so let's talk about 4F series, which is your first inner transition series, or also known as lanthanide series. Okay, so the general electronic configuration is xenon 4F1 to 14 5D0 or 1 6S2. This you have to remember. So the inert gas element presiding lanthanum is xenon. That's why we are writing electronic configuration with respect to xenon. The atomic number of xenon is 54. Okay, so in lanthanoid series, or in your first inner transition series, there are total 14 elements. Atomic number of these elements starts from 58, that is cerium, to lutetium, whose atomic number is 71. Okay, all these elements are collectively denoted by Ln, that is lanthanoids. Okay, that's why they are also known as lanthanoid. Actually, lanthanum is a prototype. Okay, so all these elements are following lanthanum, or they have same physical and chemical properties that of lanthanum. That's why they are known as lanthanoids. Okay, rare earth elements भी बोला जाता है, because earlier times it was very difficult to extract this metals from the ore. Okay, economically इतना feasible नहीं था. That's why they are also known as rare earth elements. In case of 5F series, they are also known as actinoids or second inner transition series. So the general electronic configuration is radon 5F1 to 14 6D0 or 1 7S2. Again, in this there are 14 elements whose atomic number starts from 90, which is thorium, to lawrencium 103. They are also known as actinoids. Now the presiding inert gas to the actinium is radon, whose atomic number is 86. Okay, so in case of 5F series, electronic configuration is written with respect to radon, and here it is written with respect to xenon. Okay, hope it is clear to all of you. Moving further, what is the position of lanthanoids and actinoids in the periodic table? We all know that these two series are placed at the bottom of the periodic table for the convenience, right? But that is not its actual position. Then here, this one and this one. These are the actual position of lanthanide series and actinide series, right? Sixth period, third group, and seventh period, third group. Your lanthanide series, whose starts with lanthanum. Lanthanum का atomic number है 57. After lanthanum, there is hafnium, whose atomic number is 72. So the element which lies between 57 to 72, that is cerium 58 to lutetium 71, they all place in third group and sixth period of the periodic table here. सारे के सारे elements कहाँ है? यहाँ पे. Okay, now don't get confused, because in the periodic table, as you move from top to bottom or as you go from left to right, okay, the properties of each element changes, and that's why every element is placed one after another, right? But in this case, lanthanide series or actinide series, all these 15 elements, in case of lanthanide series, all these 15 elements have similar physical and chemical properties. They are so resemble to each other that it is not possible, or it is not okay to put this element one after other. Okay, that's why they all these elements are placed in group 3 and 6 period along with lanthanum. In case of actinide series, यहाँ पे आपका एक्टिनियम है, राइट, थर्ड ग्रुप एंड सेवेंथ पीरियड में. After actinium there is rutherfordium, that is 104. So बीच के जितने भी element है from 90 to 103, all this element from thorium to lawrencium, all this element are placed in 7th period and 3rd group. Here only along with actinium, right? All these 15 elements have similar physical and chemical properties. That's why they all are placed along with actinium. Okay, I hope it is clear to all of you. Now there are some reasons which justify this position of lanthanide series and actinide series, and that are all the elements, like all these elements, 14 elements from lanthanide series and 14 elements from actinide series, all these elements have show the group valency of 3. Okay, they show the group valency of 3. Second, they all show similar physical and chemical properties. Like all the elements which present in lanthanide series, they will show similar physical and chemical properties, and all the elements which are present in actinide series, they will show similar physical and chemical properties. That's why the elements which show similar physical and chemical properties that are placed in same group. Okay, because as you go from group 3 to group 4, 4 to 5, 5 to 6, properties changes. ओके, बट इस केस में वैसा नहीं है, प्रॉपर्टी सेम है, इसीलिए सबके सब थर्ड ग्रुप में ही प्लेस्ड है. थर्ड इज, दिस इज द प्रूफ. यहाँ पे 57 एटॉमिक नंबर है, 57 के बाद डायरेक्टली 72 है, तो बीच के कहा गए सारे एलिमेंट्स यही होंगे, राइट? So this is another reason which justify the position of lanthanides and actinoids in the periodic table. Okay, I hope it is clear to all of you कि position क्या है. It is third group, 6th period in case of lanthanide, and actinide it is third group and 7th period. Okay, all the 15 elements in each series are placed in third group because they show similar physical and chemical properties. All the 14 elements are placed along with lanthanum. Okay, fine. Next is electronic configuration of lanthanoids. As I said earlier, lanthanum का presiding inert gas is xenon, whose atomic number is 54. So the configuration goes like 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6. Okay. In case of lanthanum, the atomic number is 57. Before lanthanum, it is barium, whose atomic number is 56. That means 2 electron more than xenon. So barium के केस में electronic configuration क्या होगा? It's xenon and 6s2. तो अभी जब हम lanthanum की बात करेंगे, its atomic number is 57. So the coming electron will enter in 5d orbital. Okay, electron will enter in 5d orbital and it will not enter in 4f orbital. तो 4f 0 रहेगा, 5d 1 हो जाएगा, 6s2 तो already है, right? So why this is so? Why electron is not entering in 4f orbital? Because the energy difference of 5d orbital is smaller than, sorry, the energy level of 5d orbital is smaller than 4f orbital. Okay, that's why electron will enter in 5d subshell in case of lanthanum, and 4f is 0. Hope it is clear to all of you. That's why lanthanum is d block element. Though we place lanthanum in f block, जब हम f block लिखते हैं, जब हम सीरीज सिखाते हैं तो हम lanthanum लिखते हैं, that is only because it is a prototype, या फिर हम सीरीज को lanthanoid बोलते हैं, but lanthanum is actually a d block element. Okay, it shows similar physical chemical properties to the remaining elements. Okay, but it is placed in d block. In case of cerium, atomic number is 58. Now electron will progressively add in 4f orbital, because now the energy level of 4f orbital is smaller than 5d. Okay, so the expected electronic configuration in your 4f series goes like this one. Progressively, one electron is adding in 4f subshell. Okay, 5d1 6s2 is already there, and we are adding one electron to 4f orbital. But the observed electronic configuration is somewhat different than expected electronic configuration. Why this is so? Because the energy difference between 4f orbital and 5d orbital is very low. So if f0, f7 and f14 configuration हो सकता है, राइट, या फिर आपका एलिमेंट ये वाले कॉन्फ़िगरेशन अटेन करते हैं, that means they will achieve extra stability, because this is empty orbital, this is half filled orbital, and this is completely filled orbital. And when element achieve this configuration, so they achieve some extra stability, right? So that is the reason why one electron from 5d orbital will jump to 4f orbital. Okay, the electron shift or electron can jump from one orbital to another is possible only when the energy difference between the two orbital is very low. Now in this case, electron can't jump from 6s orbital to 4f orbital because the energy difference between 4f and 6s is very high. Understood? Okay, so in this case, लैंथेनम के केस, लैंथेनम यू हैव टू लर्न लैंथेनम विद स्टार मार्क, बिकॉज इस केस में 5d में एक इलेक्ट्रॉन है. ओके, 4f is 0. Then again all 5d orbitals are 0 because one electron will jump to 4f orbital. Okay, but in case of gadolinium you have to remember this again with a star mark, whose atomic number is 64, whose expected and observed electronic configuration is same. In this case, electron will not jump from 5d to 4f. Why? Because it already have the configuration of f7, right? 4f7 already है, तो it is already half filled. Half filled है तो ये already stable है, extra stable है, right? So ये क्यों इलेक्ट्रॉन लेके खुद को अनस्टेबल करेगा, right? That's why it is 4f7, 5d1, 6s2. So this you have to remember with star mark. Next you have to remember is lutetium, again with star mark, because in this case also here you have the configuration of xenon 4f14, 5d1, 6s2. again 5d में एक इलेक्ट्रॉन है और 4f आपका completely filled है, so it attain extra stability. So in case of lanthanum, gadolinium and lutetium, 5d orbital have one electron, and in all the remaining elements 5d is 0. Okay, now how you will remember this configuration? देखो अभी लैंथेनम, गैडोलिनियम और ल्यूटेडियम का तो याद हो गया. यहाँ पे MTF है, यहाँ पे हाफ फील्ड है और यहाँ पे फुल फील्ड है. 5d1, 6s2, ये तो याद हो गया, राइट? बट इन केस ऑफ सीरियम रिमेनिंग जो एलिमेंट है, जस्ट रिमेंबर दिस एक्सपेक्टेड. 4f1 था, फिर 4f2 हुआ, फिर 4f3 हुआ. सीरियम से एक एक इलेक्ट्रॉन 4f में ऐड होना स्टार्ट हुए, राइट? तो हमने क्या किया, 5d का एक एक इलेक्ट्रॉन 4f में ट्रांसफर कर दिया. ओके, सो दिस थिंग यू हैव टू रिमेंबर. तो अच्छा ये ट्रांसफर हो गया तो अभी हो गया 4f2, ये ट्रांसफर हो गया तो अभी हो गया 4f3, ये ट्रांसफर हो गया तो अभी हो गया 4f4, ये भी ट्रांसफर हो गया तो अभी हो गया 4f5, ये ट्रांसफर हो गया तो अभी हो गया 4f6, ये ट्रांसफर हो गया तो अभी हो गया 4f7, राइट? सो ऐसे आपको याद रखने, बीच के जितने भी हैं that you have to remember. Just shift one electron, but actually progressively electrons are adding in 4f orbital 5D में एंड नहीं हो रहा है. ओके, सो दैट थिंग यू हैव टू रिमेंबर. और स्टेबिलिटी क्यों है? बिकॉज ऑफ हाफ फिल्ड, empty and completely filled f orbitals. I already told you the reason for lanthanum, gadolinium and ल्यूटेरियम. इलेक्ट्रॉनिक कॉन्फ़िगरेशन पढ़ लेना, बिकॉज क्वेश्चंस आ सकते हैं कि गिव द इलेक्ट्रॉनिक कॉन्फ़िगरेशन फॉर गैडोलियम ट्राई पॉजिटिव, देन लैंथेनम, देन प्रोमीथियम डाई पॉजिटिव. सो वो हम देखेंगे बाद में कैसे कॉन्फ़िगरेशन लिखना है, बट जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन और सीरीज का इलेक्ट्रॉनिक कॉन्फ़िगरेशन आपको आना चाहिए. ओके, now we'll see the electronic configuration for actinoids. Now in this case the general electronic configuration is radon 5f1 to 14 6d0 or 1 7s2. Now in this case यहाँ पे पूरा इलेक्ट्रॉनिक कॉन्फ़िगरेशन नहीं लिखा गया है, सो यहाँ पे क्या रहेगा? रेडॉन, because presiding inert gas for the actinium is radon, so radon हर जगह रहेगा. ये तीनों ऑर्बिटल 5f 60 7s ये भी हर जगह रहेंगे. और जहाँ पे एक ऑर्बिटल नहीं है, लाइक यहाँ पे 5f नहीं है, दैट इंडिकेट्स कि 5f ऑर्बिटल में कोई भी इलेक्ट्रॉन नहीं है, 5f 0 है. नाउ यहाँ पे 6s 6d नहीं है, राइट? यहाँ पे 6d नहीं है, यहाँ पे भी 6d नहीं है, तो इट इंडिकेट्स कि 6d में एक भी इलेक्ट्रॉन नहीं है, 6d 0 है. 7s2 तो हमेशा रहेगा, 7s2 तो हमेशा रहेगा. ओके, now here also electron can jump from 6d orbital to 5f orbital because the energy difference between the two orbital is very low. So electronic configuration of lanthanoids and actinoids are very uncertain. Okay, in fact actinoids के तो बहुत ही ज़्यादा uncertain है. Thorium का the actual reason behind the electronic configuration of thorium is still not known. Okay, because in case of actinium electron will enter in 6d. ओके, तो एक्टिनियम के केस में कॉन्फ़िगरेशन होता है रेडॉन 5f0 6d1 5f0 6d1 and 7s2, राइट? तो थोरियम के केस में इट शुड बी 5f1 6d1 7s2, राइट? बट अगेन 5f से इलेक्ट्रॉन 6d में ट्रांसफर हो जाता है और थोरियम का कॉन्फ़िगरेशन हो जाता है 6d2 7s2 5f0, अगेन बिकॉज ऑफ एक्स्ट्रा स्टेबिलिटी ऑफ MTF orbital, बट द एक्चुअल रीजन इज स्टिल अननोन, क्योंकि किसी किसी बुक में 5f1 61 7s2 भी दिया गया है. ओके, सो इन केस ऑफ क्यूरियम it is 5f7 61 7s2. यहाँ पे ट्रांसफर नहीं होता है बिकॉज ये हाफ फिल्ड है, हाफ फिल्ड है तो एक्स्ट्रा स्टेबल रहेगा, दैट्स वाई यहाँ पे शिफ्ट नहीं होगा इलेक्ट्रॉन. इन केस ऑफ लॉरेंशियम configuration is 5f14 61 7s2. So just remember the elements which are present between curium to lawrencium. Okay, बर्केलियम से लेकर आपका नोबेलियम तक जितने भी एलिमेंट्स हैं सब में क्या है 60 0 है. Okay, just remember this thing, it will quite easy to remember the electronic configuration in this way. 5f7 है 61 7s2, लॉरेंशियम 5f14 61 7s2, और बीच के जितने भी हैं एक एक इलेक्ट्रॉन 60 से शिफ्ट हो जाएगा टू 5f, जंप हो जाएगा 5f ऑर्बिटल में एंड 60 विल बी 0. बट इन केस ऑफ प्रोटैक्टियम, यूरेनियम, नेपच्यूनियम, प्लूटोनियम, ओके, इस केस में थोड़ी अनसर्टेनिटी है बिकॉज यहाँ पे 5f2 होगा 61 7s2, 5f3 61 7s2, 5f4 61 7s2, प्लूटोनियम और अमेरिशियम में अगेन 60 0 हो जाएगा, इलेक्ट्रॉन विल jump from 60 to 5f. Okay, the reason behind the shifting of electron, as I said earlier, the energy difference is very low, that's why electron can jump from one orbital to another to achieve extra stability. Okay, I hope it is clear to all of you. In next lecture, we will continue with the properties of lanthanoids and actinoids. Till then, just revise F-lock elements, electronic configuration of lanthanoids and actinoids, and keep learning. Thank you. Bye-bye. See you in next lecture.